So in number 13, we have to evaluate the function from number 13 to number 20. So we are given our function f of x. So our f of x is given as 3x squared minus 2. And we have a second function g of x. And g of x is equals to 4x squared plus 1 divided by 3x. Okay. Now, what is the one common thing do this function have? Can you just give me one common thing? Their domain is x, right? So both of these function has a domain x. Okay, for number 13, we are asked to find f of x plus 1. So we know f of x is 3x squared minus 2. We are asked to find f of x plus 1. Now, so for this function, x is the domain. So when x is the input, our output is 3x squared minus 2. Now here we are asked to find f of x plus 1. Are we asked to find the input or output? We are asked to find the output. So if we are asked to find the output, what is the input given to us? So whatever we have inside the parenthesis, this is the input. Okay. So you're going to substitute x plus 1 for every x in f function. So we're going to take f function and you're going to substitute x plus 1 for every x. So we have 3, and for x, we're going to substitute x plus 1. We have a square, okay, square minus 2. Now let's simplify. So we have 3. X plus 1 square is same as x plus 1 times x plus 1 minus 2. Okay. Now, so let's distribute 3. So we can distribute 3 for this x and 1. Okay. So 3 times x is 3x. 3 times 1 is 3. Parenthesis close, and we have x plus 1 minus 2. Now we have a binomial times binomial. So we use FOIL method. So let's multiply first terms. First term is 3x times x, which is 3x squared. Let's multiply outside terms. 3x and 1. These are outside terms. 3x times 1, that is 3x. Now let's multiply inside terms. Okay, 3 times x, which is 3x. And let's multiply last term, which is 3 times 1. We have positive 3 and we have minus 2. Okay, we use FOIL method. Now we look for the like terms. So we have 3x squared, our 3x and 3x. These are the like terms. 3x plus 3x, that is 6x. 3 minus 2, that is positive 1. And this is our final answer. This is f of x plus 1. Okay, you substitute your input x plus 1 for every x in a f function, then we then simplify. Okay, now can you do number 14? So in number 14 we are asked to find f of x minus h. Number 13 and 14, these are pretty similar. Okay, the only difference is that input is different. So instead of x plus 1, you're going to substitute x minus h. Okay, you substitute x minus h for every x and you simplify. Okay, so I will leave this for you. And can you do number 14, right? Okay, okay, let me give you 1 minute or like 2 minutes to do number 14. And those who have already done number 14, you can do number 15. Okay, it's pretty easy. Yes, h is just a variable, okay? And if you need help, just let me know. So you're going to substitute x minus h for every x in f function, okay? So final answer would be 3x square. That's gonna be 3h. That's x minus h. So we're gonna have x minus h here. Okay, so you're gonna substitute x minus h. So we have 3 times x minus h square minus 2. And final answer would be 3x square minus 6hh plus 3h square minus 2. So this is the final answer, okay? If you have this 3x square minus 6xh plus 3h square minus 2, then it's correct. Let me know if you have something different than this. Can we go to number 15? Okay, so number 15, once we know number 13 and number 14, 15 is easy, we substitute. So in 15 we are asked to find f of x plus 1 minus f of x minus h. Now let's make a substitution. So we know what is f of x plus 1 from number 13. So this is f of x plus 1, so we're gonna substitute this. So we have 3x squared plus 6x plus 1. We have negative, so negative. And we know what is f of x minus h. That's what we have from number 14. So you substitute and make sure you have the parentheses, okay? 3x squared minus 6xh plus 3h squared minus 2. And make sure you have inside the parentheses. Now we distribute negative and look for the like terms. So this is 3x squared plus 6x plus 1, negative times positive 3x squared, negative 3x squared, negative times negative 6h, positive 6xh, negative times positive 3h squared, negative 3h squared, negative times negative 2, that is positive 2. We look for the like terms. Positive 3x squared, negative 3x squared, it cancel, it is 0. We do have like term. So positive 1 and positive 2, these are the like terms. So we have 6x from here, we have plus 6xh minus 3h square plus 1 plus 2, that is plus 3. And this is final answer. Okay, 6x plus 6xh minus 3h square plus 3. Let's go to number 16. So in number 16, we are asked to find f of x plus 1 plus f of x. Okay. So we know what is f of x plus 1 from number 13, which is 3x squared plus 6x plus 1 plus f of x, which is given to us as 3x squared minus 2. You substitute and you look for the like terms. So 3x squared like terms, which is 6x squared plus 6x plus 1 minus 2 minus 1. Okay, 17, 18, 19. Can you do those numbers? You just take the, now in for 17, 18, 19, 20, you're going to take the g function, okay? Just I want you to try this 17, 18, 19 and 20, and if you have any question, we'll do this tomorrow. Okay, but it should be pretty similar, the one that we just did from 13, 14 and 15. So I'm going to skip 17, 18, 19 and 20. Okay, and if you need help, we'll do tomorrow. So let's go to number 21. So we need to find the inverse function and find the domain of function and domain of inverse function. Okay, we have the inverse function. So we need to find the inverse function from 21 to 24. Okay. So let's start from 21. So we have f of x equals to 3x squared minus 2. Okay. And the domain is given, domain for the function is given as x is greater than equals to 0. Okay, so this is the domain for our function f. It's already given. Okay. Now let's find the inverse. And the very first step of finding the inverse function is we replace our f of x by y. Okay. So we're gonna replace f of x by y. So you replace f of x by y. We have 3x squared minus 2. Okay. So you replace f of x by y. So let me write this table. Replace f of x by y. So that's the first step. Second step, does anyone recall what is the second step? We interchange. Yes, we switch x and y. So interchange x and y. So for y, we're going to write x. Okay. And for x, we're going to write y squared minus 2. So you interchange x and y. This is your second step. And the last step is we solve this equation for y. Okay, we're gonna make y by itself. So we're gonna solve for y. So we add 2 on both sides. So we have x plus 2 equals to, this is 0, 3y square. So next is solve for y. Okay, and your solution is the inverse. Now we need to get rid of 3. So we divide both sides by 3. Divide both sides by 3. So this 3 cancel. So we have x plus 2 divided by 3 equals to y square. Okay. Now we have a square. And how do we get rid of square? So we get square root, right? We get square root of x plus 2 divided by 3 equals to y. Now this is your inverse function. So you can replace y by f inverse x. So f inverse x, inverse function is square root of x plus 2 divided by 3. Now this is the inverse function. Now we need to find the domain of this inverse function. And what kind of function is this? Can you just name the type of function? Is it linear, quadratic, or a rational, or a square root function? Square root function. So this is a square root function. Okay. Now how do we find the domain for this function? So finding domain means we are looking for x, right? So that we get positive number inside the radical sign. And if we have a square root function, to find the domain, what we do, we write whatever we have inside the radical sign. So we have x plus 2 over 3. Okay, you write down whatever you have under the radical sign equals to 0. Sorry, is greater than or equals to 0. So if we have a number which is greater than or equals to 0 under the radical sign, then the expression is defined. We can't have negative number, okay? And that is why we have the number under the radical sign. So this is what we have under the radical sign. And we want this number to be greater than 0 or equals to 0. Then only our function is defined. Now this is an inequality. Let's solve this inequality. Okay, we need to get rid of 3. And to get rid of 3, we multiply by this 3 on both sides. This 3 cancel. So we have x plus 2 greater than equals to 0 times 3, 0. Okay, then we subtract 2 on both sides. This is 0. X is greater than equals to negative 2. And this is our domain. And how do we write in an interval notation? You draw a number line. From negative infinity to positive infinity, we have negative 2 somewhere here. Do we have a closed circle or an open circle? Closed. It's equal to sign, so we can have a closed circle. Now, where do we find a number greater than negative 2? On the right side or on the left side? On the right side. So you're going to write interval notation for this part. So which is from negative 2 to positive infinity. We have a closed circle, so bracket, parenthesis, and this is the domain for our inverse function.
Do we have to do the little number line?
No,
Okay.
but you must have your domain in the interval notation. Okay, if you can write the interval notation without number line, yes, you can. Okay, any question? Now for number 22, so why don't you try number 22? Okay, let me give you a time to try number 22. So our function is f of x is equals to square root of x plus 2. So you find the domain of this function, find the inverse of this function, and find the domain of inverse function. And here is the steps to find the inverse function. Okay, you replace f of x by y, you interchange x and y, you solve for y, and your solution is the inverse function. And make sure to find the domain of a function f and the domain of inverse function. So I will write the final answer. Final answer has to be, okay, that's the y and the square. I think it should be yeah. Is that what you have? Final answer, x squared minus 2. Okay. Now the next we need to find the domain of function f and domain of f inverse function. And if you didn't get this answer, please let me know, okay? You can ask for help. Let me know, I can help you. Our function f is a square root function, and square root function means you've used the same method that we did here. So you're gonna write whatever you have inside the radical sign and greater than equals to 0 to find the domain of a square root function. So x plus 2 greater than equals to 0. So you subtract 2 on both sides. So we get x is greater than equals to negative 2. Oh, we got the same domain. So this is from negative 2 to positive infinity. Okay, that's the domain for function f. And domain for inverse function, this one should be the easiest one. So what kind of function is inverse function? It's quadratic function, right? Or a polynomial function. And the polynomial function has a domain all real number. So from negative infinity to positive infinity. So every real number is a domain for all polynomial function. Yes.
So for 21, what is the domain? X has to be greater than or equals to?
That's how they define. But so it does mention that it tells us to take the x to be greater than equals to 0. Okay. So but if we don't have anything set up here, so it's given to us. Okay. Like for number 21. Okay. So we are here. So for number 21, this is also a quadratic function. Okay. But it tells us to use this number as a domain. Okay, but here it does not tell anything. Okay, it's just our quadratic function, and we can choose any number. Okay, sometimes yes, they do specify the domain. Okay. Okay, for number 23, we need to find the inverse function. For 24, yeah, you need to find the inverse function. I think I can skip 23 and 24, right? And if you need help, just we'll do tomorrow. So let me skip 23 and 24. Now let's go to number 25. So from 25 to 28, we are asked to find the domain of a function. So f of x is equals to square root x plus 4 divided by x. Okay. So this is a function. We have our variable in the denominator, right? And if we have a variable in the denominator, what we don't want, if we don't want a 0 in the denominator, right? Now, so for this function is defined And we do have a square root here. And we can't have a negative number under the square root. So we need to think. So one case. Now let's take one by one. So for what number our denominator is 0? 0, right? So it means we can't have x equals to 0. So x is not equals to 0. That's okay. Now we also have a square root here. So what kind of number can't we have for x if we take the numerator, this one? So let's find the domain of numerator here. So what is the domain of numerator? X greater than or equals to -4, right? Okay. So, okay, I think it's going to be easy if we draw a number line. So we have a number line, all real number. So let's consider all real number is a option that we have here. So 0 is not a domain. So we have a 0 and let's exclude 0. It means we're going to have an open circle. Okay. And for the numerator, any number which is greater than, or now for the numerator, what we do, we write x plus 4 greater than equals to 0. If we solve this, we get x greater than equals to -4. So this is the domain for the numerator. So it means, so from -4, so we have -4 here all the way to the right side. Okay. And we do include -4, right? It's a closed circle. Now greater than 4, we go here, this part, and this part is the domain for this function. Okay, so we write down in the interval notation and make sure we are excluding 0. Okay, so the first part is from -4 to 0. -4 is included, so bracket, 0 is excluded, so parenthesis, and the second part from 0 to positive infinity, 0 is excluded, so parenthesis, with infinity always parenthesis, and union, and this is the domain for this function. Okay, so if you have a rational function, you have to exclude the number that make denominator equals to 0. And if you have a square root function, you have to exclude the number that gives you negative number under the radical sign. Okay, any question? Okay, let's go to number 26. So in number 26, we have f of x equals to cube root of x plus 5 divided by x squared plus 6x plus 8. Okay. Now, so we have a quadratic function in the denominator. Now, for what number our denominator is equals to 0? And the easiest way is to factorize our denominator. Okay, so let's factorize our denominator. So we have a cube root of x plus 5 divided by, we use the FOIL method. So x is the first term. So two number whose product is 8 and sum is 6, which is positive 4 and positive 2, right? So can you tell me x for which our denominator is equals to 0? So when we choose our x equals to -4 and -2, our denominator is equals to 0, right? So we can't have these numbers as our domain, okay? So x can't be equals to -4 and -2. Now what about the cube root of x plus 5? What kind of number can we have for this expression to define? Any number? Okay. So if we have a, let's say, we can find the cube root of negative number, right? So for example, if we have a cube root of, okay, so let's say if we have a cube root of -27, so we can rewrite this as a cube root of -27 is a cube of -3. So this cancel and we have -3. Okay, so here, so this is a cube root. Okay, so earlier we had a square root. Okay, we had a square root here, so we had a square root. Now we have a cube root here. Okay, So we can have any number for the numerator, but we can't have these two number in the denominator. Okay, it means, so we have a number line, negative infinity, positive infinity. We can't have -4, so open circle. We can't have -2, open circle. Okay, but we can have any number less than -4, any number between these, and any number on the right. So our domain is from negative infinity to -4, parenthesis, union from -4 to -2, union from 2 to positive infinity. Okay, 27 should be the easiest one. What is the domain for 27? F of x is 1/3 x cubed minus 1. This is a cubic polynomial function. So all real number from negative infinity to positive infinity. If you have any polynomial function, all real number is the domain. Okay, for 28, so we have f of x equals to 1 over x square and fifth root of 3x plus 2. So we have the denominator, so we don't want a number that makes denominator equals to 0. Now let's find what numbers make denominator equals to 0 for this function. Okay, 0, so let's exclude 0. Do we have any number that makes 0 in the denominator? So what if we choose x equals to -2/3? If x is -2/3, we have 0, fifth root of 0, and fifth root of 0 is 0. Okay, so what you can do, you can solve this. You can just write this expression equals to 0 and solve for x. So 3x plus 2 equals to 0, subtract 2, 3x equals to -2, x equals to -3/2. So we have -3/2, and when you choose x equals to -3/2, the function, we have 0 in the denominator. Oh, sorry, it's, yeah, thank you, it's 2/3, -2/3. So -2/3. So we exclude these numbers, but any other number is the domain for this function. So we have negative infinity to -2/3, union -2/3 to 0, union 0 to positive infinity, and this is the domain. You don't need, okay, we did, but you don't need to worry about for the function which has the index greater than 2, okay, like the cube root, fifth root, you don't need to worry. But make sure you know how to find the domain of a squared function, okay? Yeah, squared function, rational function, polynomial function, okay? Okay, do you have any question up to here? Okay, now let's go to number 29. So we need to perform the following transformation on the given parent function. Okay, you are given the basic function and you need to perform the transformation and graph the function, and we also need to graph it. Okay, and you do have the formula sheet. Okay, there is given the transformation. Okay, it will be given to you. You should be able to read those transformation. Okay, now in number 29, so our basic function f of x is x squared, and we need to graph the function g of x is equals to -x squared plus 1. This is what we need to graph. Okay, let's start by drawing a graph for this basic function. So what kind of basic function is this? This is a quadratic function, and the graph of a quadratic function is parabola, right? Okay, now our target, now we are starting from basic function, okay, and our target is getting -x squared plus 1 from x squared. Now let's see what is missing here. in the basic function. So we need to have a negative in front of x square, and we need to get positive 1, right? Now, how do we get negative in front of x square? What do? We multiply by negative 1, right? Now, if we multiply by negative 1, what kind of transformation is this? Reflection across? Okay. So it's a reflection. You need to write the transformation, okay? Reflection across x-axis. And what happens to the graph when you reflect across the x-axis? It flips, right? So we're gonna get this graph. So this is the graph, okay, after reflecting across the x-axis. Now we need +1. So it means, how do we get +1? We're gonna add 1. So add 1. And our f of x becomes negative x squared plus 1. Now what does it mean by adding 1 to a function? We are shifting graph vertically up, okay? So shift vertically up by how many units? By 1 unit, okay? So let's say our graph is at 0. Now let's shift up by 1. So we're gonna have 1 here. So graph is, okay, this is the graph that we're gonna get, and this is our g of x. Okay, so this is g of x.
Do we have to draw every step?
Now you are not required to draw every step. Make sure you draw the basic function and the final graph, and you need to write down the transformation, okay? Here it does, and make sure you are writing this transformation. So what you can just write in a single sentence, like you start from this basic function, reflect across x-axis, and shift vertically up by 1 unit, okay? Or you can just show every steps, and just try to use a different color, okay? If you are drawing a graph in a same Cartesian coordinate system, just try using different color for a basic function and final graph, okay? So this is for number 29. Okay, let's go to number 30. So in number 30, we have our function, basic function is square root of x. This is the basic function, and we need to plot a graph for x, square root of x plus 2 minus 3. So what kind of function is the basic function? Square root function, right? So let's draw a graph for a square root function, and the graph of the square root function looks like this, okay? Okay, I did use the red, okay. So this is the graph for a square root function, okay? So we are starting from this basic function, and this is what we need to get. If we compare, what differences do we find? For x, we have x plus 2, right? And we have negative 3. Now, how can we get x plus 2 from x? What do? We replace, right? So we replace x by, so we replace x of a basic function by x plus 2. Now, what kind of transformation is this? If we are replacing x of a function by x plus 2, and you do have the formula sheet, okay? You can, okay? So we shift our shifting horizontally on the right or left? Left, okay. Shift on left side by how many units? 2 units. By 2 units. This is 0. Now left on 2, so negative 1, negative 2. So this is negative 2. So we're gonna draw the similar graph starting from negative 2. Okay. So our f of x becomes, after replacing x by x plus 2, this is what it becomes. Now we need to get negative 3. And how do we get negative 3? We subtract 3, right? Subtract 3. And what kind of transformation is this? Shift down. by 3 unit. So this is -1, -2, -3. Okay, and we shift this point all the way at here, and we draw a similar graph. And this is our g of x. And on your formula sheet, this clearly, okay, I think they have used the arrowhead, right? Do you have a formula sheet? Let me see it. And, okay, I hope you all can read. So here, yes, for x plus c is just left, okay? I think you should be able to read this one, okay? It will be provided to you. Okay, okay, why don't you try number 31 and number 32? Okay, so let me just give you some time for number 31 and 32. So 31 we have f, your basic function is a cubic function, and the function that you need to graph is x minus 4 cube plus 2. And you should know the shape of a graph, okay, for the basic function. And if you are confused, you can use the points and you can plot. So let me draw a graph for the basic function, and you do the remaining. So this is a cubic function, and cubic function has a graph that looks like this, okay? So this is a cubic function. Okay. Now graph g of x using transformation. Make sure to write every transformation that you used. And let me know if you need any help. So what would be your first step? You're gonna replace x by x minus 4, right? So you're gonna replace x by x minus 4. And replacing x by x minus 4 means you are moving right by 4 units. And then you're gonna add 2. And adding 2 means you're gonna shift vertically up by 2 units. So you go right by 4 units and go up by 2 units. So this is 1, 2, 3, 4. So you draw a graph similar. And you go up by 2 units. 1, 2. So this is. So you're gonna draw a graph. And this is your g of x. Okay, number 32, we have, what kind of function is this? It is absolute value of a function, right? Absolute value function. And the graph of absolute value function is, what is the shape of graph for absolute value function? V shape, right? Okay. So this is the basic function. So we start from here. And graph g of x. So the first, you need to have the negative in front of absolute value. Okay, so multiply by -1. It means you are reflecting across x-axis, right? So this is your graph. Then the next, you're gonna replace x by x plus 5. It means you are moving your graph on the left side by 5 unit. So this is -5. So this is, and you have the -1, then you subtract -1. It means you are moving your graph down by 1 unit. So this is -1. So from here you draw V shape, and this is our g of x. Do you have a question up to 30? Yes.
So what would this look like if it was reflected, like what would the equation look like if it was reflected across the y-axis instead?
Oh, if it was a reflection across, okay, so reflection across y-axis, how do we get that? So we replace x by -x. So if we replace x by, okay, now if you have a confusion, you can use the table. Okay, so let's start. So we have this, okay, so this is our y equals to absolute value of x. So if it is reflection across y-axis, then we replace x by -x. Okay, now I think we're gonna get the same. See, absolute value of -x is absolute value of x, right? We're gonna get the same graph. Okay, you just imagine that. So reflecting across y-axis means you just imagine you just place a mirror here, okay, and x-axis means you place a mirror here, and just think about the image that you see on the mirror. Okay, for example, if we have a, okay, so if we have our this is the square root function, and if we reflect across y-axis, then this is the graph that we're gonna get. Okay, if we reflect across the x-axis, this is the graph that we're gonna get. Okay, now let's go to number 33. So we have a graph given to us from number 33 to 35. Let me draw the graph here. So it starts from -5, 4. So -5, 4. Then -2, -3. So -3, -2. -3, -2. Negative. So this is +4, -2. And 7, 7. Okay. So this is given to us. Okay, and we are asked to graph the f of x. No, this is the give f. This is f of x. We need to find. Okay, so this is what we need to find. So we need to find f of -x. F of -x plus 3. Okay, so this is what we need to find. And this is the output. Okay, this is the y value. Do not get confused. This is your output. So what you're gonna do is here is that you're gonna make a table. So make a table x. Okay, write down the every x values, which is -5, -3, +4, and 7. Okay. So when x is -5, so when our x is -5, our y is 4, right? When x is -3, our y is -2. And when our x is 7, y is 7. When x is 4, our y is -4. Now what would be our output when your input is -x? So let's write down negative x here. So negative x is negative of this number. So positive 5, positive 3, negative 4, negative 7. So what happens when we choose our input to be negative? Yes, so when we choose our x, when we choose to be negative x, what will be our output? So this is like replacing x by negative x, right? So when we replace x by negative x, what happens? There occurs a reflection across y-axis, right? Now here, so when you choose your negative x for x, there occurs the reflection across y-axis, okay? Now what happens to the output here? What will be the output here? So you have to reflect. So you have to reflect across y-axis, and you add 3. Now, okay, now let's go back here. Okay, for example, so let me take this point. So we have let me see this point here. So the coordinate of this point is, okay, 4, 2. Okay. Now, when we reflect this point across x-axis, what would be the coordinate of this point? The x coordinate remains same, y coordinate changes its sign. Okay, so when you are reflecting across x-axis, you're going to have the same x coordinate, but the y changes its sign. Okay, but if you are reflecting across y-axis, so if you are reflecting across y-axis, the coordinate of this point, the y remains same, the coordinate of y remains same, but the x changes to negative 4. So it's going to be negative 4, 2. So reflecting your graph across y-axis means you are changing the sign of x coordinate. Okay, you just flip the sign of x coordinate. It means you are reflecting across y-axis. And if you are reflecting across x-axis, you are changing the sign of y coordinate only. Okay, so in general, if you have a point x, y, okay, and if you find, okay, so if you take a point negative x, y, so x as it is, just you change the sign of x, then that is the reflection across x-axis. Okay, but if you switch the sign of y, if you switch the sign of y, then you're gonna get the reflection across x-axis. Okay, okay, just using this concept, try number 33, 34, 35. Okay, if you can do, it's good. If not, we'll do tomorrow. Okay.